Hello, friends. In our day to day life, different applications like Zomato or Swiggy or even Ola Uber, you must have seen that when we do some kind of booking, we keep waiting when the driver or the delivery person would come down and hand over, or we would be getting the cab. We often keep watching our screen as the movement of the driver or the delivery person goes on, and we can view every move that the person goes through until he or she reaches to the target point. This is something what we commonly view in any mobile application and all modern which are very popular based app we come across. The question is how these things are achievable, and if you are working on Django, a backend server framework, do that has a the feature to implement such kind of functionalities. Yes, Django do serve a feature which would provide you a real-time communication, and this is actually done by using Django channels. So when you give an order to your pizza, the delivery person, what movement he or she does can be tracked by the backend server with the help of Django channels. In case if you are working on Python, or if you are working on Node application, it will be with the help of Socket.io. The common feature between these applications is that they are real time. What do I mean by real time? We will cover that in this particular video. So right now what you can see over here is I have created one Django application. Now when you create a Django application, if you go to the project folder, I must believe that you must have seen that there are two files. One is called WSGI and other one is ASGI. What these two files are, that is something we need to understand now. So if I open WSGI, this is a very few line of code you will find, and the similar kind of thing you will find in ASGI. But if I open ASGI right now, you will find few more code which is not available by default. Let me open this file as well. This is something what you are seeing right now. Along with this, I will also take you to settings.py, because inside the settings.py, if you give a minute look, then you will find that this kind of statement is written in every Django default application that you will be creating. Now what is the relevance of this? And again, this is an interview question that you might come across when they will be asking you this question, that what is the relationship between WSGI and ASGI. Okay, let's get into this question. By default, every Django application supports HTTP request and response. I repeat, every Django application by default supports HTTP request and response feature, and this is all done by WSGI, Web Server Gateway Interface. And that's the reason why inside settings.py you will find WSGI underscore application. This line is written, and you will find the name of the project, whichever project you are using. Inside that you have a file called WSGI, and inside that you have got something, a variable called application. That is what actually been written in this line. So every Django application by default supports HTTP request and response, and HTTP request and response is not real time. I repeat, it is not real time. So the case study which I provided just few minutes ago, if you really want to implement that using HTTP request and response, it is no way possible. Hence we have to move to ASGI, which is asynchronous server gateway interface. And when you work on ASGI, you're basically working on WebSocket. So WebSocket would provide you the data in real time, and for that reason we need to make use of Django channels. So next time if someone asks you what is the meaning of WSGI and ASGI, the answer to this question would be, by default when you are creating a Django project, it comes up with WSGI, whereby it will allow you to perform HTTP request and response. HTTP request and response is not going to work on real-time data or on WebSocket. The reason is HTTP request response work on the principle of not remembering the client after the transaction has been completed. What do I mean by that? Well, when a client asks a resource that can be an HTML template to the server will verify the authenticity of the user, and after checking that it will provide you the template, and then it will disconnect the state. For that reason HTTP is a stateless protocol, so it will not retain the state after delivering the request or after fulfilling the request. Whereas in case of real-time data transmission, or when you will be using the WebSocket, at that point of time you have to set up the connection and you have to continue the connection as long as you want. So that might take 5 minutes to that of 1 hour, and that's the reason why you can track the movement of the driver or the delivery person where he or she is, and this is all done with the help of socket. And for that reason you need to have channels. So channel will provide you a continuous flow of data, so there will not be a termination. As long as you want, the channel will continue providing the data, and that is all done by asynchronous gateway interface, asynchronous server gateway interface. So when you want to implement Django channel, you have to comment WSGI and you have to activate ASGI application, and you have to give a call to the ASGI file, and inside this you have to do a bit of configuration. Let me show you that configuration right now. This is the updation that you have to do it. So what this updation is all about: firstly, in order to implement asynchronous communication or WebSocket implementation, you need to install a couple of dependencies. So let me take you to settings.py and let me scroll up over here. The first thing is that you need something called daphne. What this particular package would do is it will create the asynchronous server. Okay, so daphne will create the asynchronous server, and this will provide you the way of interacting with the channel. So you need to implement these two packages. So pip installation of daphne and channel are required in order to implement the WebSocket, and this is very important. So once you have implemented these two dependencies, now you are able to modify your ASGI. So ASGI will get modified, and how it will modify? Let's come to the ASGI part over here. So since you are going to work with the WebSocket, for that reason it will implement a new channel implementation. So for which, as you can see over here, we have got channel.routing. Well, by default the way your application used to work is used to have urls.py file. Over here your HTTP request is used to get in, and then you would like to see the URL pattern, and eventually you would either give a call to the app URLs, or you might give a call to the view method. That's how, and the view would serve the request or response. That's how the thing used to work. But now in this case it's not going to work in that fashion, because you have to create an environment where both HTTP request response can also be served. At the same time the WebSocket request and response also need to be served. So now in case of ASGI, you have to implement the environment in such a way that both web page request in the form of HTTP and the real-time data in the form of WebSocket should be implemented, and for that reason you need to implement the channel.routing. So channel.routing will provide us the protocol type router, and with the help of the protocol type router you can implement both type of transactions. So it will allow you to access our traditional HTTP request, that was basically your WSGI. At the same time it will also introduce the WebSocket, which is our ASGI, and WebSocket will have its own URL. That means the regular URL.py which you used to use, that will not come in picture. You need to have a different form of URL, and that's the reason why I have to make use of this particular statement. So let's move on this particular statement, but before that let me tell you that I have created one app. So if I expand my app folder, I have got an app called chat app. Inside this chat app, if I expand it, by default whatever files you get inside any app, along with that I have to create, or if you want to implement Django channels, you have to come up with two new files. One is called consumers.py and other one is called routing.py. These two files are very much required, and what is the relevant of these two files, I will definitely tell you that. But before that, I would like to talk few minutes about the daphne that we have installed, and this will be very important. So for that reason I've written a short note about daphne. So let me take you to that and let me read out this information so that you do understand why daphne is very important. So daphne is actually going to provide us the asynchronous server gateway that runs Django application using Django channels, because we want to implement the real-time data transmission, and that are often required in any chatting applications. Okay, so for that reason we need daphne, which will provide us the ASGI server. So unlike the default Django run server, so when you fire the command python manage.py run server, what actually happens is that it actually supports HTTP, but HTTP will be fine, but this is not going to work in case of real time. So for that reason we need daphne, which will support both WebSocket as well as any other real-time protocol as well as the HTTP. So daphne is more compatible compared to run server, because daphne will allow you both the functionalities. You can work on WebSocket, at the same time you can also work on the HTTP request. So by default Django uses run server, which we know very well, and it works on WSGI that handles the HTTP. So this is the interview question which I was referring. But Django channel need ASGI to support WebSocket and asynchronous communication, and that's the reason why daphne will allow you to make this possible. So when you install Django run server, you cannot work on WebSocket. For that reason you have to install daphne, and in order to run your server, development server, you cannot use now python manage.py run server, will not work. Rather you have to use the following command. Daphne -b is basically used for binding. That means you are binding the daphne application with the following server IP address running at the following port number, and here you are giving a call to the project name, that is the project in which you are working, by_book, and inside that there is a file, or you can say there is a module called ASGI, and that module has a variable called application. Let me show you that, and here it is. So if you look at this, this is the thing I was referring. This is the variable which I have mentioned over here, which you have to mention the time when you will fire this particular command. And in fact, if you go to settings.py, if you scroll down over here, also I'm mentioning to that particular variable. So if I click on this, it will take me to my ASGI file. See, it opened the ASGI file, and if I click on this, it will take me to the variable which we have created, which is of type protocol type router. The protocol type router coming from the channel.routing will allow us to work on both type of request. So HTTP request also will work, at the same time WebSocket is also going to work. So remember, in order to run WebSocket we have to fire this command, so the traditional python manage.py will not work in that case. So Django provides by default WSGI, which I have said, meaning there is no real-time communication is not going to work. So we have to wait. We will get the data when the user requests the data, and there is no live update taking place in the background, because once the request has been served, the HTTP protocol will disconnect the connection. So for that reason there is no data exchange in the background. Since there is no continuous connection, channel layer is what required. So we need to work on Django channel that will provide some layers, and through this layer the data communication is going to work. So layer will provide us a special pathway through which the continuous communication of data will be exchanging between both the parties. So all the messages between client, that is your WebSocket, I will talk about this client more in details. So we know the server is there, so they have to interact among each other, and for that reason they need a channel layer. And this channel layer you have to apply inside your settings.py. So if I scroll down over here, this small configuration you have to do it. So since we are working at the production, like I'm not working at the production level, rather I'm working at testing level, for that reason I'm using the channel layer dot in memory channel layer. So in memory channel layer actually refers to the RAM that the server has got. So that means the data exchange will be taking place with the help of the RAM provided by the server. But when it is in the production mode, at that point of time we have a special package called Redis. So with the help of Redis we can go for the channel layer. Until then, let's talk about this in memory channel layer. So right now what is happening is, when we are exchanging data between a WebSocket, it needs a channel. Through that channel the data communication will be taking place all the time. Well, I can understand you might be confused, so let me show you a graphical illustration. I believe that will help you to understand it better. So imagine there is a browser. The browser is going to work, the browser is going to provide data in the form of web, HTTP request, or it can ask for WebSocket. So now what is happening is, when we have implemented Django channel, so there will be a channel, a layer will be there, and this layer is provided by your RAM. In memory we are using. So when you are putting a request, the request can be an HTTP request or a WebSocket request. That request will first come to the channel. So the channel is capable of handling both type of request. It can be an HTTP message request. Message means like what traditionally we do, WSGI, and it can also provide WebSocket, that is ASGI. So whichever request you are providing, that will go to the intermediate state, which is a worker process. So the worker process will determine whether the request which you are putting forward, is it an HTTP request. In that case it will go to the traditional view.py, which will give a call to the respective function, and thereafter you will be seeing the HTTP request will be accepted and HTTP response will be forwarded, like what we often do in the traditional application. The same thing we are doing right over here. Okay, so let me zoom it a bit so that you can understand in much better way. So that means the traditional approach which you often follow, the same thing what I am talking about. So HTTP request will send the request to the view.py, which contains view method. So the view method will request the data and will respond either some JSON data or maybe the template. That what will be happening if it is of type HTTP request response. But in case of WebSocket, remember this entire thing is coming from the channel, so the channel has to be implemented, and that's the reason I did the settings. In the settings I did the configuration where I was using the in-memory channel. So if it is finding WebSocket, then it will give a call to something called consumer. Over here also the consumer was there, but the consumer was in the form of HTTP. But in case of WebSocket, we have got something very special called consumer that we will be seeing. So the consumer will be responsible for handling your request and response. We will see, don't worry about that. And the consumer will also perform some background task, that can be some database access, that also can be taken care. So in short, when we are working on Django channel, we need to have an extra layer called channel layer. So this channel layer will be responsible for both handling HTTP message in the form of request and response, as well as WebSocket message in the form of real-time and asynchronous communication. Via this channel the implementation has to take place. So if it is in the development stage, at that point of time you can work on your inbuilt memory, but when we'll work on the real-time application, then we have to work on Redis. Now let's focus on the actual Python channel. So for that reason this particular picture will be very handy, but let me first show you what the channel is all about, then we'll come back to this picture once again. Okay, so we saw that we have to implement this channel configuration, we saw that we have to implement this ASGI, and we also saw that how asgi.py file need to be configured so that it is capable of handling both HTTP request response as well as WebSocket. Okay, this is something which need to be done, and once you have done the configuration inside the settings.py, you are putting forward that from now onward I will not use WSGI, rather I will be using ASGI, and once we are using ASGI, we need daphne, and daphne we will run the server with the help of daphne with this particular command, which we will see right now. So now let me copy this command and I will paste it. But before I do that, let me close WSGI, because WSGI is of no use right now. Now I will be coming to my app. So let me come to my app, and inside my app there is a particular app called chat app, where I want to implement the real-time implementation. As I was saying in the diagram also, I was showing that the regular view file view.py will not be used in context to Django channels. We have to use something called consumers.py. That's the conventional term which we often use in case of channels. So if I double click on this, you will come across some code snippet and we'll understand what this particular file is all about. Now, one more modification will be required if you are working on Django channels. Your regular urls.py will not be used right now. Rather, we have to work on a new file that is called routings.py. So that means when you are implementing Django channel, there would be some changes which you need to apply. The very big change was WSGI got replaced with ASGI, because WSGI was handling data in the form of HTTP request and response, and the problem was HTTP was stateless. It cannot remember the state after serving the resource to the client. So for that reason we came to WebSocket, which is actually stateful, which will remember the state, and since it remembers the state, so the data communication will be going on in between the channel as long as you want. That can be hour after hour, days after days. Okay, and that's what we see in applications like WhatsApp or Instagram. That is something that happens. Now when we are implementing ASGI, we have to give a call to channel. We saw that, and we also saw that protocol type router is capable of handling both the traditional HTTP and WebSocket. This we have understood by now. But the big change that is required is we cannot work with our regular urls.py file. It will be replaced by routing.py, and our regular view.py will be replaced by consumer.py. So these two big changes are required over here. Okay, so now we will understand what these two files are all about. So first we'll get into the routing.py to understand what the thing is, what we are going to do actually. Well, as we can see right over here is inside my routing.py. Remember, this routing.py is actually the replacement of urls.py of my app. So over here I have to bring some changes. So first change is that the regular path function which was present inside Django.urls is now replaced by re_path. Re stands for regular expression. So this path will have a regular expression that will be implemented. And the second important thing is that I have got consumer.py file. I need to give a call to that, because inside the consumer, which is actually your module that contains a class called chat consumer, which I have written over here, that need to be called. So chat consumer will be called with the help of the consumer file. So how exactly this is going to work, and how exactly this route is going to work? Well, you know, in your actual project there was urls.py, that is still there. So urls.py, here it is. I will give a call to chat / and that will give a call to my app. This is my app name. So apps is a folder name, and inside that I have an app called chat-app that has a urls.py file which I'm giving a call. So this line is very important, right, which we have to do always. Now how will you give a call? So we don't have a regular HTML template over here right now. Rather, in the diagram I was showing that I will be using something called WebSocket client. So here is where my figure 2 lies. So I need a client, and for that reason we will be using something called, which is an online like platform. You can think this as a substitute of Postman. So suppose when you're working with REST API, you use Postman for evaluating your API. In the same fashion, if you're working on Python channel, you can use this WebSocket King as your WebSocket client, and the Django server will always be there. So let me take you to the browser, and here it comes. Here it is. So this is the website that is called websocket.com, websocketking.com. So this is a website that we will be using, and I have to, what I will be doing is that I need to run my Django server. So I said that I will be using my daphne, which is going to bind with the IP address, and the port number is the following, and I'm going to use my project, that is a bybook, which is giving a call to asgi, and within that there is a variable called application. Let me show you one more time, because I know these things are a bit confusing initially, I can understand. So asgi comes up with a variable over here called application, and this application is what map inside settings.py right over here. So if I click on this, it will take me to this particular variable initialization, where protocol type router will allow me to both HTTP and WebSocket, and moreover this is going to implement the channel. Okay, see over here the channel is already there, so all the request and response will go through the channel. So that's something we have to keep in mind. So let me hit my server over here to start, and as I do that, the server has already started. See, it's listening on the TCP, and this is the IP address and the port number. Okay, so it's already there. Now what I will be doing, something this is very interesting. So for that reason, what I will be doing is that I have to give a call to my routing. So how will I call the routing? With the help of the regular expression hyphen path. So look over here how the path function is going to work. Since you are going to work on WebSocket, a very important point is this: since you are going to work on WebSocket, you are not supposed to use the HTTP protocol any further. Rather, you are going to use WS protocol. WS stands for WebSocket. So this is the protocol that you need to use in order to work on WebSocket. Please keep it in mind, since you are working on WebSocket, you cannot use HTTP protocol any further. Rather, you have to use WS protocol. So WS protocol : the name of the IP address of your server, I mean the IP address of the server, the port number, and then what I'm going to do is that I have given a regular expression. See, it has a exponent at the beginning. It means that the starting string would be chat followed by WS followed by test, and that would how it ends. After that there would be no other substring followed by this particular URL. So I have to copy this particular thing. So I will be copying this and I will paste it in the WebSocket king. Please follow again the line what I am saying. Since we are working on WebSocket, so HTTP protocol is no longer going to work. Rather, WS protocol will be working. Just like HTTP, here also we have to mention the IP address followed by the port number, and we have to mention the entire path. Since we are using regular expression, so that's the reason it has the letter R, which stands for regular expression, and it is saying that the string should begin with the word chat and the string should end right over here. After this there should not be any further string associated. So once I will be writing this, just like your regular urls.py file, what you used to do when you used to write the path, that will give a call to the view. Over here the chat consumer is actually a view, and since it is a class type, so we have to convert it into the you have to convert into ASGI format, asynchronous server gateway interface, so that it can work with the ASGI. So for that reason we have given this dot for as underscore ASGI. So it is going to convert this class into the ASGI format. So that means, just consider again, this is similar to the urls.py file. Here we have the URL pattern. Well, this is the term which I have written. You can write whatever term you feel like, that's not a big deal. So this particular thing, but remember this particular thing will be written inside your ASGI file. So let me open ASGI once again. So inside your ASGI file, here you are writing your route, here you are giving a call to that particular variable. So if I click on this, look, it brings me to this particular variable. So your ASGI must be aware about your path, because I said when you are working on Django channels, there will be a channel which we saw in the diagram. The entire channel is there. So the request would first go to the channel. The channel has to decide whether the request type is HTTP or the request type is WebSocket. If it is of type HTTP, then it will redirect to the view function, but if it is a WebSocket, then it will forward it to the consumer. So for that reason, this mapping is very much required, and this is the entry point of your Django channel. So here we'll end up, and here is my route mentioned. So I have got currently one particular route, and that will take me to this particular class, and which will be converted to ASGI. So let's come to the class now, and this class is where you can consider this class to be equivalent to your views.py file. Okay, so routing.py is equivalent to urls.py and consumer.py is equivalent to views.py. So over here we have got three different functions, and these are the lifecycle method of Django channels. In this particular video, I will be focusing on the most fundamental part of the Django channel. It's a very big topic, and in fact I have thought to make a complete playlist on this particular topic, and this is like a first video in this particular playlist where I will be just talking about the basic requirements needed to implement Django channel and to understand how the framework is actually working. Okay, so what we have done over here, we have created one class and gave the name as the chat consumer. By default, the term consumer is commonly used as a convention, and this is inheriting from the class called async WebSocket consumer. Well, there are two type of consumers, one called just WebSocket consumer, which is basically synchronous, but I want to work on asynchronous. Now if you're working on asynchronous, it can support lots of requests coming from different endpoints, so that's the reason asynchronous communication is much better than synchronous communication. If you have smaller requirement, then you can go for synchronous communication. Okay, so now what I will be doing, so let me come to my browser over here and let me show you something. So this is my WebSocket. So the WebSocket is working as a client, and let me open my diagram even. So let me bring you over here. Imagine this is my client, this is my WebSocket king, and this is my Django server which is actually running right now. So WebSocket will send a request. By the way, if you remember in networking, there used to be three steps process, there's a handshaking method that was going to perform three steps. So exactly those three steps are over here even. So the phase one is like setting up the connection, phase two is for sending data, and if you are completely done, then we'll go for phase three, which will be like breakdown or breaking your connection. Okay, so there are three different phases through which the entire connectivity takes place, and that's what I will be covering in this particular section. So WebSocket is your client and Django is a server. Maybe later on your WebSocket client can be replaced by a mobile app, Android. It can be a React application also, that can be your client. So that means your client can be of different type. An iOS application can be a client, an IoT application can be a client. So the client will be interacting with the server, and the server will forward the data to the client. And for that reason, we want to make use of Django channels, because this communication will persist. Not like HTTP, that after server serves the request to the client, server forgets about the client completely. That's not going to happen over here. So over here, the path, the channel will keep on transmitting data as long as you want, unless you personally tear down the connectivity. So the first thing what we will do is that the client is going to send a request to the server that it wants to set up the connection, and for that reason we will give a call to the very first function that is called connect. Inside my Django application, inside the chat consumer, there are three different methods are there, and these are all system defined. They are going to work with asynchronous format, so async keyword is there. As we know in JavaScript, if you want to work with asynchronous, so we have to give the keyword async. So in order to set up the connection, the first method that will be called is connect. Once the connection has been set up, if you want to exchange data in between WebSocket client and your Django server, again I'm telling WebSocket client can be Android, WebSocket client be an iOS, it can be React. The socket is sending the data to the server, and the server is responding by the data. That's what will involve the receive method. And finally, when WebSocket decides that no more further communication is required, you can, if you want to come out of that, then the disconnect method will be called and the connectivity will be teared down. So what I will be doing is that I will be going to my browser and I want to set up the connectivity, and for that reason I will copy the URL which I did from my, here is my my server is already on. As you can see, the server is on, and now we will come back to our application and I will copy the URL. So routing, if you go, this is the path that you have to implement. So I will copy this particular endpoint, and since we are working on Django channel, which will make use of WebSocket URL, and for that reason WS should be used, not HTTP. Remember this, a WebSocket will have a separate protocol. And now if I go for connect, what will happen, it will connect to my server. Please keep an eye over here, the server is already running, but it is not connected yet. So when I will tap on connect, the control will come down to my URL, and that will take me to this particular class. Inside the class I have a system function called connect. Let me see what the connect is. When the response is coming from the client to the server will accept the connectivity. So self.accept means server accepted the connectivity that is coming from the client, and then server will print a message in the terminal. I mean, in the Unix terminal, I will be seeing that is web server connected, and I have to mention this information to the client also, that yes, you have successfully able to connect. So client also need a message to see that whether the connectivity has taken place successfully or not, and for that reason we will be using something called json.dumps. I know this particular video will be a bit longer, but what I want is that in one particular video I want to cover up this fundamental part, so that if you repeatedly listen to this video, the whole thing will be crystal clear. Now when the server is going to send the data to your client, how exactly data will be forwarded? Because the client is heterogeneous, right? The client can be React, the client can be Angular, the client can be Android, the client can be iOS. So for that reason, the client needs the data in such a format that irrespective of whatever type of client it is, the client can view the data. So for that reason, this particular function will come in picture. Import JSON I have done .dumps. What dump will do is it will convert the Python dictionary into JSON string, and we know that JSON is compatible with any type of framework or library. So I have a key over here called message, and I have given a value over here. It's up to you what key you determine, what value you determine, totally up to you. So this is a Django dictionary, but that dictionary is handed over to json.dump. It will convert this dictionary into a JSON string, and that will get stored inside the variable called text_data. I have given the name, whatever name you feel like you can give it. And now I will be firing a command called self.send. Self.send will do what? The Django server will forward this particular variable, which is JSON string, to the WebSocket client. So that means WebSocket client will able to see the data within itself. Let me explain the whole thing once again. So here is my WebSocket. I have written this particular URL. Now when I will click on the connect button, this response will go to the server, and here is my server. The server will receive the response, and it will print a message over here that yes, the connectivity is successful, but that message came in the terminal. How come the client will see? So for that reason, client will also see a message for which Django did what? It has created one dictionary, but it converted the dictionary into an universal format so that any form of client can view it, and that is done by json.dump, which has stored a variable in the JSON format, JSON string, and with the help of send, which Django is sending, it will send the data back to the WebSocket client, and the WebSocket client will display this particular value and can see it. Now let's go and run the application, and let me open the server over here. So forget about this particular thing, what is, you are not seeing anything as such. So now if I go for connect, please take an eye over here. As I click on the connect, the moment I do that, see the WebSocket connected. This is coming from this particular print statement, WebSocket connected. Immediately our Python Django created one dictionary. The dictionary was converted into text format, JSON string format, and that string is right over here. And Django server, or you can say Django channel, use the send method to send the data to the WebSocket client, and that's the reason why you can see this message coming from client, you connected to the server successfully. So this message is coming from the server. See this arrow, look at this arrow. This arrow is pointing that the message is coming from the server to the WebSocket client. So the client is now connected, and as the client is connected, you can see over here there is no command prompt being back, it is still running. And not only that, look over there, a few minutes ago it was showing connect, but now it is showing disconnect. That means the connectivity is on, and this is where the channel comes in. Let me take you back to the image once again. So I said you that once the connectivity has been established, the channel will come in picture. The channel will retain as long as you are not disconnecting. And that's the big difference between HTTP request response and WebSocket. This is the beauty of Django channel, that you can go for asynchronous communication as long as you want. See, the connectivity is still persisting. It will continue as long as you want. So that means the data exchange between client and server can take place. Okay, so with that, the first method got clear. So the first method was to set up the connectivity, and in my diagram I even illustrated that the client first requested to the server accepted that, and after that the server created one message, forward that message to the client, so that the client do get to know that yes, the connectivity has been successful. Now the client will again initiate a process whereby it will send some data to the Django server, and in response to that, Django server can send back a response. So for that reason, we will have another method called receive. So receive method means the client, which is the WebSocket, will send some data to the Django. So let's look at the second method of the chat consumer class, receive. The term receive means server is receiving some data coming from the client. Okay, it's not the other way around. Client is not receiving anything. The name receive over here means the client is sending data. As I can show in the diagram again, the client is sending some data to the server, and the server is receiving that data. So whatever data client is sending, that will be passed to this particular parameter. So here I have got one parameter, whatever name you want you can give it. So this parameter I will be using for sending data. But how exact data will be sent? So if you come to the browser, look over here, I have got a payload. So here exactly I have to create my object, and then I will click on the send button. So this data which I am sending will be considered over here in this variable. So whatever data I will be sending, that data will be received by the Django server and will be stored over here. So definitely Django need to get hold of the data. So let me expand the function now. So this message will be printed in the terminal that Django received the data coming from the WebSocket client. Now what we have to do? We have to collect the data that has been sent by the Django, by the client, right? So whatever data I'm going to send over here, the data will be in the form of a key value pair, will be in the form of a JSON. So JSON, we have to forward the data. So I have to write some key over here, and then I have to write some value over here. So key value, in this format I will be sending the data, right? So for that reason, what I have to do, I have to write one key. So what I'm doing over here is the incoming data is in the form of a JSON. To be more specific, this data that is sent by the client to the server is in the form of a JSON string. So but Python doesn't work on JSON string, it works on the dictionary. So for that reason, just the opposite of the method which we were doing, JSON.dump, JSON.load will do what? It will receive the JSON string and it will convert that string into Python dictionary, and it will store inside this variable. So this is a very important method which is just an alternative of the following method. So JSON.dump is going to convert the dictionary to string, and JSON.load is going to convert JSON string to dictionary. Because the incoming data coming from the WebSocket is always going to be JSON string, it need to be converted into Python dictionary. Okay, and then we will see what we will try to find out inside that dictionary, is there any key called message. So I will try to use this particular key so that I can collect the data from the dictionary. So I will create one key by the name called message, because in the code I have made a message, I have made use of the word message. So I will put the message over here, and whatever message you want you can write it. I am enjoying the session. Okay, so I wrote one key, and this is the message I have mentioned. So when this data will come to the receive method, so first Django will convert your incoming string to Python dictionary, and it will store that over here. Then from the dictionary it will try to get the value from the key, the name of the key is message, and whatever value it will get, it will store it over here. Okay, and now what I'm doing is that, like what I want is that if I send a value called by, then the connectivity will be disconnected. If I send a value called by, but I didn't send the value called by right now, as you can see over here, my value is something called different. I am enjoying the session. But in case if I would have sent a value called by, the connectivity will be disconnected. We'll see little later on. So if condition is false, it will come to the else part. So now what it will do? Well, I have written this inside the entire send function. You can split this apart. You can cut it from here. You can store it. Just a second. Control Z. I have to write it this way. If you want to save time, you could have written that inside this, and then I pass it over here. So again, I'm writing one dictionary over here. So this is my dictionary. I am writing a response, and what message I have received from the client, I want to redirect it back to the server once again. So I created one dictionary, and that dictionary got converted to JSON string, and that JSON string I'm sending it back to the client. Or if you want, you can send whatever value you want, but I have appended it by saying that you sent the following value which I have collected. Okay, So this piece of code I wrote it over here. So right now if I run my code, what will happen? If I click over here, I will get this response back, but in that this particular statement will also be there, use send. So let me show you over here. Now if I click it, I will click my terminal also over here. If I click it over here, let me click it. See, you're getting the message. See, response, you sent, I'm enjoying this session. So look at the arrow. This arrow pointing that the client has sent the data to the server. So that's the reason it's showing the upper direction. So the data went from the client to the server, and here the data came. See, then the server, I have got the data. Okay, just a minute, let me have a bit of water. I know this video is pretty lengthy one, but as I said that I want to complete the fundamental part in one video, so that in the next video I can highlight more in detail about this one. So as you can see over here, this data came from the WebSocket client to the server, and the server received the data in the form of, initially it was JSON string, then got converted into dictionary, and then server also sent back a response. See, you sent, I just appended this string in from the server side, and the value whatever user has sent, I'm just enclosing that and I'm forwarding it back to the client. So over here interaction is going on. So if I want to send another message, that also I can do it. It's pretty cool. So this is going from the client. So when client will forward the data, it will be in the upper key direction, and on receiving that, the server will also send back a response like you sent. It's pretty cool. So you will see both the directions. See, it went first, and then it came to the server received that, and the server sent back a response to this. So right now it's between the client and the server, but later on there can be multiple users also, like what we do in the chatting application, and that's what we will be achieving in the upcoming sessions, right? But in this particular session I just wanted to show you the basic framework of Django channel. What are the minimum requirements to have, so that if you have been asked an interview, you can come up with at least these answers. That's pretty good enough. So data came from the client to the server, and server to the client is going pretty smoothly. And now what I want is that I want to terminate the entire process. So what I thought is, I didn't see over here I have an option that I can disconnect. I can click this disconnect button, the disconnection will take place immediately. So if I click on this disconnect button, what will happen is that it will give a call to this disconnect function. I will be seeing this message called disconnect server. Let's do it first, then I will be talking about the if part. I'll be talking a little later. So let me click on this disconnect button. See, still the server was on. So if I click on the disconnect button, immediately you will see the message called WebSocket disconnected. See, disconnected, that means it is no longer connected. The WebSocket has been disconnected. So that means you gave a call to the disconnect method, and this print statement got fired. So you can well understand how these three lifecycle methods are interconnected. They know when to call which one, right? So that's how this particular thing was working. Okay, and again let's start from the very beginning, from the scratch. So let's start the application once again. Let's go for connect. So as I click on the connect button, see the connection started, and the disconnect button is on, so I can continue my interaction, right? So we disconnected from the socket perspective. What about the server perspective? Can I disconnect from here? Yes, even if you stop the server, automatically this disconnect button will change, will get removed, and you will get connect. See, if I close my server over here, I'm closing my server. As I do that, immediately it got disconnected, and now it is connected. See, disconnect took place. So either way it will work. So if you are disconnecting from the client, the server will also disconnect. If you're disconnecting from the server, your client will also get disconnected. So that's how the channel is connected. Okay, so either way it can work. Okay, so let me start my server once again. This server started, and let me clear the screen, and let me connect the client, and the client also started very well. And now I can continue my interaction with the client and server. So I can send a message that great going, and I click on the send button. The client sent the message, the server received the message, and the response came back. Now what I'm going to do is that, rather clicking on the button, what if in the message itself I'm sending one data called buy? Well, in that case what happens, the disconnection takes place, but before disconnecting, a message has been sent to the client that server is now going to get close. This Python dictionary been converted to JSON string, and that JSON string is forwarded to the client with the help of the send method from Django server, and then it is giving a call to self.close, and the connectivity will be disconnected. if I follow this approach, what will happen is the client will get a message that the disconnection is taking place. But if you directly close the button, or if you click the server, I mean if you stop the server, the client will not get the message as such. So if you are good with that approach, that is also you can do. But I felt like if I pass it in this fashion, at least the client will get this message and then the disconnection takes place. So I will just write the word bye. Okay, well, I just took the word bye. You can put whatever you feel like, nothing special about that. So I'm just putting the word called bye over here. The moment I will do that and I will click over here, first it will receive this message that server is closing now, and then the disconnection will take place and the disconnect button will not be there anymore. Rather, it will replace by the connect button. So let me send now. As I do that, over here also disconnection will take place. See, it received the message and the WebSocket got disconnected, and disconnection took place over here, and the disconnect button is no longer there, rather it's a connect button. So you send the message bye. The message bye from the client went to the server figured out that this word is the word to stop the connection. It sent you this particular message, server connection closed, and then it terminated the entire process. Oh my god, it's been a pretty long video. But overall, the bottom line is the following picture is very important. So in order to work on Django channels, these three phases you have to go through it. And along with that, there are a couple of functions that was very important. One is json.dump and json.load. What json.dump was doing is that it was required by the Django server to send a message to the client. So since Django server was creating a Python dictionary, so dictionary has to be converted to JSON string. That was done by the json.dump. Similarly, json.load was working on the part of the client. So when the WebSocket client was sending data to Django server, it was in the form of a JSON string, and Python need to convert the JSON string into Python dictionary. And that's how this interaction was going on. Well, in this particular video, what I tried to show you was the basic flow of control that you need to implement in context to Django channels. And you also understood how WSGI and ASGI plays a very important role in the execution of whether it's an HTTP request or whether it's a WebSocket. So from now onward, if somebody asks you that when you are working on a Django project, by default what are the files you are getting and what are the objective of those files, you already knew what is settings.py, urls.py. You knew it very well, but these two files were not been discussed. But now you have understood that WSGI is responsible for performing HTTP request, which is basically a stateless. So once the server sends the data, after that it forgets about the client. But in order to implement a real-time communication in the form of asynchronous data transfer, we have to make use of ASGI. And in order to make use of ASGI, we need to use daphne server, which will provide us ASGI support along with that Django channel, so that the interaction between the data and in form of client and server through the channel takes place. Okay. So that's all from this video presentation. I hope you understood the flow of control, but this is a special playlist which I am making in context to Django channel. In my upcoming days, I will be making more videos right from here onward. Okay, until then, have a nice time. Bye bye.